In this video, we will go over Pandas' own built-in capabilities for data visualization. These are built on top of Matplotlib but baked into Pandas for easier use. This allows us to call the visualization directly off the data frames. So let's start by importing our libraries and data to work with. The CSV files will be linked in the description box in case you want to practice the codes alongside me. Otherwise, feel free to just watch along. So here we will start by importing NumPy as NP and Pandas as PD. We will also import matplotlib.pyplot as PLT, and we will run the one line code matplotlib space inline to show the visualizations in the Jupyter notebook. Now there are a couple of CSV files I want to use. Those files are linked in the description box. So let's upload those using pd.read_csv. Just pass in your file name. Remember the file has to be in the same folder as your Jupyter notebook. Otherwise you will need to give the full file path here. So let's check this files first. So here we have a column called unnamed. This is basically the dates. We want to set this as our index here. So what we can do is df1 is equal to df1 dot set index, and we will pass in if you want to check the name of the column, we can do df1 dot columns. Here to set this column as an index, we can use df1 dot set underscore index and just pass in the name of the column and copy paste from here. And now if you check the df1 dot head, this is our index here. Let's check the head of df2 as well. So these two are basically just data sets which has random data for 4 columns A, B, C, D. Let's quickly check the info for this as well. So df1 has total of 1000 entries. The index is dates, and then we have 4 columns A, B, C, D, which all of those has float data, and there are no null values here. Now let's check this for df2 as well. Once again, df2 has only 10 entries, row index going from 0 to 9, no null values, and all are floating data. So now that we have these data frames, let's say you want to visualize this data. So Pandas comes with some built-in data visualizations. There are different plot types which we can plot using the Pandas data frame directly. So we have the area plot. For that we have bar plot, density plot, histogram, line plot, scatter, bar again. So the difference between these two is this is vertical plot and bar h is for horizontal plots. So the base of the plot would be on the y-axis. Then we have Boxplot, Hexbin, KD, and barplot. So to use these plots, we can directly plot this using this command. So with our data frame, just use dot plot method, and then you can pass in the kind argument for the kind of plot we need, or we can replace that kind argument with any of the key terms shown in the list above. So first, let's start by using histogram. Let's say for this first data frame, for this column, we want to check the distribution of data here. So what we can do here directly is, let's call our column, and then we can directly call plot, and then for kind pass in hist here, and as you see it will plot a histogram here. So now here we can also pass in the matplotlib arguments which goes with this kind of graph. So for histogram we can pass in matplotlib histogram parameters. So one of those we know is bins, that is for number of bins you want. So let's say we want 30 bins, and we can pass in that. Now this graph just on itself doesn't look very good. So what we can do is we can use style sheets here. So matplotlib has style sheets which we can use to make plots look a little nicer. These style sheets include BMH, 538, ggplot and more other such styles. These basically create a set of style rules that your plots follow. So if you Google matplotlib style sheets, hopefully you will land up on this page on matplotlib website. It has examples of different style sheets available for use and how those plot will look. You can check those out. Just go to the style sheets reference. Here you can see how the plots will look for these style sheet options. So to use these style sheets, we have to use this command plt.style.use and then pass in your option as string. And here if you look at the different options given here, this is how the plots will look. By default, the matplotlib plots will look like this. If you pass in classic, this is how the plots will look. Similarly, you can check for other options as well. Here we have BMH, dark underscore background. So the background is basically in black, and then there are other color combinations available for that. Then we have fast, we have 538, and then this is our ggplot which we will use for this video. So this is how our plot should look, and there are other options as well. You can check those out. So the way to use it is plt.style.use. So what we can do here is you can run this command plt.style.use, and then you can pass in the kind of style you want, the kind of style you want your plots to follow. So here let's say we want to see ggplot. Now if we plot the same graph once again, let's say we copy this command and we run it again, and see the color for that has changed. Now we don't see any boundary lines here to differentiate between the bins. What we can do here is pass in the matplotlib parameter age color, and we can pass in k here. K is short form for black, and now this will show these colors. Now if you want, you can change this line width as well. Let's say we want thicker lines, you can pass in 2, and those edge lines will become thicker now, or you can make it thinner as well. Let's say you want white color, you can pass in white here, and these lines will be in white now. Let's go back to black. Now let's say you want to try different style sheets as well. Then we can use plt.style.use, pass in bmh, and now let's run the same code once again, and see this will be in a different style here. We can try a dark underscore background as well. So let's say plt.style.use, pass in dark underscore background, and then we will run the same code and see the background for this style is black in color, and the plot itself will have different colors. Let's try another one. Let's try 538, and this one has different style as well. Uh, here the labels and numbers are in white. It doesn't go with the background, to be honest. Also, if you see, we do not have the top spine and the right spine here on the graph. But if you look at this dark underscore background, we have those top and right spine here. So these are just different kind of styles. If you want to maintain consistency across your Jupyter notebook, you can run one of these styles at the top of your notebook, and then all of the plots which you plot will have the same style. Now, before moving on, Let's go back to our ggplot. That is what we will follow for the rest of the video. So, now there are two ways of plotting this graph. One you saw here. What we did was we used the either with the data frame or with the column, we used dot plot method and then pass in the kind of plot you want under the kind parameter. Or what we can do here is we can directly pass in commands like this. You can use dot plot, dot area, or dot bar h, or all of the other options given here for that kind of graph directly. So for this histogram, it will be df1a. For this column, we want to use the plot method, and then we want to use the hist method. Just run this and we will get our graph. Now here we want to change the number of bins, let's say 30. Then we want an edge color as well, that would be black, and we want a thinner line, so we can pass in 0.5 for that under LW. LW is short for line width. Now next, let's move on to the area plot. So here what we can do is, let's go for our second uh, data frame df2. We can use dot plot dot area and just run this command. Very quickly it will give us an area plot for all of the columns in the data frame. There were 4 columns, A, B, C and D. We can also use the alpha parameter here to increase the transparency. So here this plot is not very beautiful, it's not very presentable, but it's good enough for a quick analysis of the data. Now let's move on to the bar plot. For the second data frame, we can use df2 dot plot dot bar. Run this and it will give you bar plots for each of the rows here. Now remember, bar plot is used for categorical data. So for so if you look at the docstring here, you can pass in your x and y. If you have a data frame where there are numerical data and then categorical data, so on the x-axis you can pass in your categorical column, and on y-axis you can pass in your numerical columns. Or if you have multiple numerical columns, you can pass in a list for this. So here what it is doing is, because we didn't pass any categorical columns, it is taking all of the rows itself as categories. Now here we have only 9 rows. If you check the data frame, we have only 10 rows. Actually we have only 10 rows, and that's why we can plot a bar plot for this. However, if you have 1000 rows, we cannot realistically be using a bar plot with a data frame like this. What you will be doing most likely is, if one of the columns is categorical, you will be using that. Now here we can also stack all of these bars on top of each other. So for that, just pass in the parameter stack is equal to true, and it will stack all of the bars on top of each other for each of the rows. Next, let's move on to the line plot. So let's say you want to plot line plot of the data given. So remember our df1, if you check the head, was a time series, because the index is essentially dates. So let's say if you want to plot a line plot for this, what we can do is plot dot line, and if you check the uh, docstring, once again we can pass our x and y for this. If you have a column which you want to use on the x-axis, you can pass that on the x. Otherwise, by default, it will take the index as the x-axis, index on the x-axis, and all of the columns should be taken on y-axis unless you specifically define one of those. C allows plotting of one column versus another. If not specified, the index of the data frame is used. Similarly for Y, if not specified, all numerical columns are used for Y. So if we don't pass anything, it will automatically take this index on the x-axis. So we won't bother for X. For Y, we can directly pass. Let's say we want column B here. So we can pass Y is equal to uh, B, and it will plot a line plot like this. So right now it's not very intuitive. The lines are too thick. So we can do a couple of things. First is the figure size. Let's say we want a wider figure, so we'll pass in 12 by 3. The other is line width. Let's say we want thinner lines, so we can pass in 0.5, or let's go with 1. So now this is a lot more intuitive. You can see the data going up and down with time. Graphs like this are usually used for time series analysis while analyzing stock data or stock price movement. Graphs like this are also used for measuring earthquake or seismic movements. Now next, let's move to scatter plots. Now scatter plots are to analyze bivariate data. So let's say for this df1 we will use dot plot dot scatter, and for once again, if you check the docstring, we have x and y parameters here. So we can pass in our x and y data. Then we have s, which is for size, and c, which is for color. So first let's check for x and y. So for x we will pass in our column A, and for y we will pass in our column B. And this is the graph. Once again, if you want, you can pass in each color here. Let's say we want black for that, and you can change the thickness of that. And we can also pass in the color parameter. Let's say you want the plots on red, so it will give you a red scatter plot, so it will give you a red scatter plots. But now let's say you want this color to vary based on some other column. So what you can do here is, rather than this color parameter, let's say for C, you can pass in a third column, and then as the data varies in that third column, the color here will vary. You can change this color mapping here. You can use CMap, and let's say you want cool warm palette, you can pass in that. So here the color will vary. For higher numbers we have data in red, for lower numbers on the negative side the data is in dark blue, and for numbers in the middle the data is very light. So the darker colors both on both extremes, on the higher number would be dark red, and on the negative side would be dark blue. So this is used for divergent data when you want to highlight both extremes and not the data in the middle here. Or you can go back to your previous palette. I think it was Viridis by default. You will have something like this, where the higher numbers are in blue, lighter numbers are in yellow, and it's get darker and darker as the numbers move higher. There's another way to vary that. For some of the data, sometimes you don't want to change this with color but with size. So what we can do here is, let's say for this scatter plot, x is A, y is B, and rather than changing color, sometimes you want to vary the size. And then here we cannot directly pass a column because this doesn't make any sense. The numbers are too small, so you can't see anything here. What you can do is take this column from the data frame and multiply it with a scalar value, and now those scatter plots would be a lot bigger. Once again, we don't see the edges here, so we can pass in the edge color parameter for K for black, and now it's a lot more intuitive. Now let's move on to the box plot. Once again, box plot is for distribution of the categorical data. You can pass in any of the categorical columns, but we don't have any categorical column here, so we will use our columns itself as categories here. Let's say for df2 dot plot dot box, let's run this, and we have numerical data in all four columns. So for all four columns it will give us a distribution of that data. Here we have uh, min value, 25th percentile, 50th percentile, 75th percentile, and max value. Remember, this will ignore the outliers here, and we have that distribution for all of the columns here. Now next is Hexbinplot. Now Hexbinplot is used for bivariate data, which is an alternative to scatterplot. So here, let's say on df1 dot plot, we can pass in the hex bin method for Hexbin plot. For x, we will pass in column A. For y, we will pass in column B. And let's run this. Now here, it's very hard to see anything because of the small size. So you can change the grid size here. If you look at the docstring, we have this grid size parameter. If you go down, this is the number of hexagons in the x direction. So right now, there are a lot of smaller hexagons here. That's why the size is small. Let's say we want only 25 hexagons on the x direction. So it will divide uh, this plot from -4 to +4 into 25 equal size on the x-axis, and similarly it will have a corresponding division on the y-axis as well. And now these grids are bigger. Let's say if you try 10, it will have much larger grids. If you go with only one, entire thing would be one single grid. So for 1 it gives an error, for 2 it will have 2 grids, for 3 it will have 3 grids here, for 4. As you keep increasing, the number of grids here will continue to increase. So for 25, and here the grids which has more data in that will be darker, and grids which has lesser data would be lighter. Now you can change the color for this as well. We can use cmap parameter and pass in oranges. Let's say you want orange color, and it will show a map like this. Now next, let's say we want to see the KDE plot. So for this df2 data frame for a column, we can directly use plot.kde, and for this one line it will plot the KDE plot. Let's say you didn't want the histogram, you just wanted to see the KDE plot. You can use this command here, and we can also check the density. It's basically the same thing whether you use the KDE plot or if you pass in the density. Here we are not selecting a column, we are doing for all four columns here. So for each of the column it will plot a KDE plot or the density plot, whatever you want to say it here. Now that's all for this video. Hopefully you can see why this method of plotting is a lot easier method than to use full-on matplotlib. Also, it balances the ease of use with reasonable control over the figure, as we can use the style sheets. A lot of the plot calls also accept these additional arguments for the apparent matplotlib plt dot calls, so we can pass in those parameters as well. Now these plots are really for quick analysis, and if you want a nice customized plots which you can present to others, then you shouldn't be using this. You should be using seaborn plots, which is also designed to work very well with pandas data frames, so that's not a worry. So that's all for this video. Until next time, see ya.